Good morning, everyone. This is the first video that I'm making, and it has to do with the fundamental theorem of calculus. There's actually two parts to the fundamental theorem. There's an evaluation part, which we have used for a number of weeks now, and that's shown up here at the top, is that if we have the integral from a to b of f of x, then capital F here is any antiderivative of f on AB. That's the evaluation part. Now the antiderivative part states that if f is continuous on the interval AB, then the function f of x is equal to the integral of f from a to x and has a derivative at every point x in AB, and df dx is equal to the derivative with respect to x of a to x f of t dt, and that is equal to f of x. Now notice the two different parts. So this is an evaluation part where we find an antiderivative, but here we are stating that capital F has a derivative which is equal to little f of x here. So let's look at three quick examples. Okay, so if I have this integral, then the derivative is just going to be f of x, which comes from f of t as stated above. So what we end up with then is if I take the derivative of this integral, then I will get sine squared x. If I take the derivative of this integral, then I will get x cubed minus x. And if I take the derivative of tangent cubed, I get tangent of x. And it seems very basic, but the reason it seems basic is that we have an integral, we're finding an antiderivative of sine squared, and then we're taking the derivative of that, so we end up really with what we started. Now those are three basic examples just because we're integrating from a to x. But let's look at some that are a little bit more complicated. Okay, so what if I integrate not from 0 to x, but 0 to x squared? As we did before, we would end up getting e. We're going to replace t now with x squared, but that would give us e x to the fourth power. But we need to invoke the chain rule here. So this would be times 2x, because the derivative of x squared is 2x. Now, in the second example, again, a little more complicated than the first ones, is every place that we have a u, we're going to replace that with 5x, but then we have to use the chain rule. So this would be the square root of 1 plus 5x squared over 5x, but then the derivative of 5x is 5. Now, this 5 and this 5 can simplify, and so our final answer then would be the square root of 1 plus 25x squared all over x. Okay, now this example has a little twist to it, because instead of integrating from 6 to x, we're integrating from x to 6. So what we first will do is rewrite this as 6 to x ln of 1 plus t squared dt. And then that would lead us to negative ln of 1 plus x squared. Okay. Now, this one you might be able to anticipate. What we're going to do first is we're going to switch this from 5 to x cubed cosine t over t squared plus 2. And then our final answer would just be negative cosine of x cubed. And then what we have is, this is x cubed squared, so that gives you x to the 6th plus 2. And then we're going to multiply by 3x squared.